Good morning, everyone. Today, I want to discuss with you the van der Waals gas equation for real gases because I have already discussed the van der Waals gas equation P plus an square by v square v minus nb is equal to nRT. What is A and what is B now? A is the measure of attractive forces between the molecules, means how much forces that is playing in between the molecules to attract those molecules, and it tells us that whether a gas can be liquefied or not, because if there is attractive forces, then gas molecules that are far away from each other can attract each other. And so how they can attract each other? If we apply the pressure on the gas molecules. Okay, if A is large, then the attractive forces is also large. Okay, and gases are more compressible. You can relate A with Z. If Z is less than 1, means what? More compressible. I have already discussed this Z value in the last video. I'll give you the link in the description box. More compressible. Okay, A is very large. Now what is B? B is incompressible volume. Incompressible volume means we cannot compress this volume, so we have excluded this volume. This is also called excluded volume from the whole gas, from the volume of whole gas. Volume of whole gas. Suppose this is the area that was previously covered by the molecules. These are the gas molecules, okay, that are far away from each other. But when we compress this gas particle to this small volume, they are going to take some volume of the container. So this can be the excluded volume. Because there is some attractive forces between the molecules, we can compress them to a small volume, and this is the total volume for the gas. V is equal to, means V dash is equal to V minus NB. These are the number of gas molecules from where we can exclude the volume. Okay, so this was the significance of the van der Waals parameters or van der Waals constants P plus an square by v square v minus nb is equal to nRT. Now, if I want to tell you regarding the units of A and B, this is very much important from the NEET point of view and JEE point of view. So how we can calculate the units of A and B? You don't need to remember these values. Just I want to tell you, if there is plus sign or minus sign, only the parameters with the same unit are going to add or subtract from each other. For example, P plus an square by v square. If this is the pressure is in atmosphere, Pascal, anything. If this quantity is pressure, then this whole quantity is also pressure, and its unit is atmosphere. So you know that volume can be in liter, can be in decimeter cube, can be any other volume like centimeter cube, milliliter, or anything else. Okay, an square by v square is equal to atmosphere. Okay, n unit is mole square, divided by volume unit is liter square, atmosphere. Okay, now we can calculate A is equal to, by cross multiplying it, and this is going to divide that atmosphere liter square mole minus 2, because it is going to divide by mole square, and mole square after going to above mole minus 2. Okay, now what is the unit of B? V minus NB, right? This is volume, so this whole term will also be volume. V is equal to NB, or V by N is equal to B. V is liter, N is mole, B. So unit of B is liter per mole. Okay. Now, what is the applicability of van der Waals gas equation? Applicability of van der Waals gas equation. Have you cleared the units of A and B? Because this is very much important. Applicability of van der Waals equation. You already know that from now. P plus an square by v square, v minus nb is equal to nRT. If for 1 mole a by v square, v minus b is equal to RT. Okay. Suppose I have three conditions. What it is at low pressure. If the pressure is very low, then the gas particles can move from here to there. Volume will be large. This V term is very, very large than the excluded volume. Okay. So I can neglect this B and I will have P plus A by V square into V is equal to RT. PV plus A by V square into V is equal to RT. V cancel with V square. PV plus A by V is equal to RT. What is Z? Z is compressibility factor whose volume is PV divided by RT. Okay. So I can divide this. What I can do? I can divide this RT on both sides. PV divided by RT plus A by VRT is equal to 1. What is this? This is Z. Z is equal to 1 minus A by VRT. I have already discussed that when the attractive forces is high, Z is less than 1 and the gases are more compressible. Okay. This means that if the attractive forces are more, Z is less than 1. Okay. Now at high pressure, P is greater than V minus NB is equal to nRT. V minus P is equal to RT. PV minus PB is equal to RT. Divide both sides by RT. PV divided by RT minus PB divided by RT is equal to 1. PV divided by RT is what? Z. So this term can go there. So this is in negative sign and on the right hand side it will be positive. 1 plus PV divided by RT. Okay. At high pressure, Z value is greater than 1. At high pressure, Z value is greater than 1. Okay. At high temperature and low pressure, volume is large and pressure is also, and we can neglect A by V square because attractive forces is going to very small at low pressure. Okay, so PV is equal to RT. This is what? Ideal gas equation. I have already told you that at high temperature and low pressure, the gas molecules are going to be far apart. Okay. There is no attractive forces between the molecules and volume is also going to be very large. Thank you so much for watching.